There is a plant growing in all 50 states that produces more calories per acre than rice. You can eat its roots, its shoots, its pollen, and its seed heads. Native Americans built entire civilizations around it, harvesting it for 10,000 years as a primary food source. A single acre can feed a family of 4 for a year. You can prepare the first edible parts in 30 minutes with nothing but a knife and boiling water. And you've never seen it sold in a single grocery store in America. Not at Whole Foods, not at farmers markets, not in the organic section, not anywhere. They did not ban it. They did something more effective. They drained the land it grew on, reclassified wetlands as wasteland, and let a 7,500-year-old food system vanish in a single generation. This is the story of the supermarket of the swamp that industrial agriculture arrays. The archive opens in the wetlands of the Great Lakes region, 10,000 years before Europeans arrived. Across what we now call Wisconsin, Minnesota, and Michigan, indigenous peoples were not just foraging. They were managing vast cattail marshes as deliberate agricultural systems. The Ojibwe, Potawatomi, and Menominee nations understood something that modern agriculture has spent a century trying to forget. Wetlands were not wastelands. They were the most productive farmland on the continent. Cattails, which the Ojibwe called apakwi, were not weeds. They were staple crops that required zero tilling, zero irrigation, and zero fertilizer. The plant did all the work. Humans simply harvested what grew. The preparation knowledge was precise and passed through generations. In early spring, when the shoots were 6 inches to 2 feet tall, they were cut at the waterline. The outer leaves were peeled away, revealing a white core that tasted like cucumber and hearts of palm. These were eaten raw or boiled. By early summer, the immature flower heads appeared, still green and wrapped in leaves. These were harvested before the pollen formed, boiled, and eaten like corn on the cob. They called them swamp corn. In late summer, the pollen was collected, a fine yellow powder high in protein. It was mixed with other flowers to make bread. And in fall and winter, the real treasure was harvested. The rhizomes, thick starchy roots that spread horizontally through the mud, were dug up, washed, and processed into flour. One food plant, 4 distinct harvests, available year-round. But the caloric math was what mattered most. A well-managed cattail marsh could produce between 6,500 and 15,000 calories per acre, depending on soil and water conditions. Compare that to wheat, which yields roughly 4 million calories per acre, but requires plowing, fertilizing, pest control, and an entire industrial infrastructure. Cattails required walking into shallow water and cutting what you needed. The labor input was a fraction of grain agriculture, and the land required was wet, meaning it could not be used for other crops anyway. To indigenous communities, this was not primitive survival food. This was high-efficiency agriculture in ecological niches that other crops could not touch. They were farming the water. And then the settlers arrived. In 1734, a French explorer named Jean-François Bisson-Cosme documented cattail use among Great Lakes tribes, writing that the root, when dried and ground, produced a flour comparable to wheat. By the 1800s, American naturalists like Henry David Thoreau were writing about cattails as a famine food, acknowledging their edibility, but dismissing them as a resource for desperate times. The knowledge was recorded, but the cultural value was already being raised. Settlers saw swamps as obstacles, not resources. Wetlands were something to drain, not cultivate. When researchers finally measured what was inside cattail rhizomes, the numbers should have rewritten agricultural textbooks. The starchy roots contain 30 to 46% carbohydrate by dry weight. That is comparable to potatoes. But potatoes require planting, hilling, pest management, and arable land. Cattails require mud and water. The protein content of cattail pollen reaches 15 to 20%, higher than wheat flour at 10 to 13%. The young shoots contain beta-carotene concentrations comparable to carrots, vitamin C levels similar to tomatoes, and small amounts of vitamins B1, B2, and niacin. This was not just calories. This was complete nutrition in a plant that grew wild in every ditch, pond, and marsh across the continent. The USDA's own publications from the mid-20th century acknowledged all of this. In 1943, during World War II, the government published guides on wild edible plants, listing cattails as a reliable food source for civilians facing rationing. The instructions were straightforward. Harvest the shoots in spring, the seed heads in summer, the pollen in late summer, and the roots in fall. Every part was edible, and every part was abundant. For one brief moment, the government promoted the same plant that indigenous peoples had relied on for millennia. But after the war, something shifted. Industrial agriculture needed land, and wetlands were in the way. In 1954, the Small Watershed Act authorized the federal government to fund drainage projects that would convert wetlands into farmland. By 1977, over half of the wetlands in the contiguous United States, more than 221 million acres, had been drained. The official reason was agricultural expansion. Corn and soybeans needed space. Wetlands were classified as unproductive. Cattails, which had fed indigenous peoples for 10,000 years, became an obstacle to progress. The marshes were drained, the cattails were plowed under, and the knowledge of how to use them was buried with the plants. Here is what they do not tell you. The decision to drain wetlands was not just about creating farmland. It was about creating dependency. A farmer growing corn or soybeans must buy seeds every year. They must purchase fertilizer, pesticides, and herbicides. They must invest in equipment. They must take out loans. The entire system is designed to require external inputs. Cattails require none of that. You cannot patent a plant that has been growing wild for 10,000 years. You cannot sell inputs for a crop that fertilizes itself. You cannot create a supply chain for a food that anyone can walk into a marsh and harvest for 3. From an economic perspective, cattails were not just unproductive, they were unprofitable. And then there was the perishability problem. The young shoots, the part that tastes most like a vegetable, begin to oxidize within hours of being cut. They turn brown, just like a cut apple, because of enzymatic reactions when the cells are damaged. In the 1950s and 60s, refrigeration and distribution infrastructure were not advanced enough to get fresh cattail shoots from a marsh to a grocery store before they looked unappetizing. Even if someone wanted to commercialize them, the logistics were prohibitive. So the plant fell through the cracks, too labor-intensive to harvest at scale, too perishable to distribute, and too free to monetize. But the regulatory contradiction is the detail that reveals the agenda. In 1972, Congress passed the Clean Water Act, which included protections for wetland vegetation. Cattails, as wetland plants, were suddenly protected by federal law. You could not drain a wetland without a permit. You could not harvest wetland vegetation without permission. But at the same time, the USDA and state agricultural departments still classified cattails as noxious weeds in the context of irrigation ditches and farm ponds. The same plant was simultaneously protected as critical wetland habitat and condemned as an agricultural nuisance. The contradiction created a regulatory maze that ensured no one would attempt large-scale cultivation. If you tried to farm cattails, you would need wetland permits. If you tried to harvest them from public wetlands, you would need foraging permits. The bureaucratic barrier was more effective than any outright ban. The suppression was not accidental, it was structural. Compare cattails to rice, the most similar crop in terms of water requirements. Rice is grown on over 160 million hectares globally and generates hundreds of billions of dollars annually. Entire industries exist to sell rice seeds, fertilizers, pesticides, milling equipment, and distribution networks. Cattails, which grow in similar conditions and produce comparable or superior calories per acre, generate zero industrial revenue. No seed sales, no chemical sales, no equipment sales. The economic incentive is not just absent, it is inverted. Every person who learns to harvest cattails is one fewer customer for industrial agriculture. And the knowledge keepers who tried to preserve the information were marginalized. In the 1970s, Ewell Gibbons, the most famous wild fruit forager in America, wrote extensively about cattails in his book, Stalking the Wild Asparagus. He called them the supermarket of the swamp and documented every edible part. The book became a bestseller, and for a brief moment, cattail foraging entered the cultural conversation. But Gibbons died in 1975 at the age of 64, and no comparable figure emerged to continue the work. The knowledge receded back into survival manuals and niche foraging communities. Mainstream food culture moved on. Meanwhile, indigenous communities never stopped using cattails. The Ojibwe in northern Minnesota and Wisconsin still harvest them in traditional territories. The Paiute in the Great Basin still gather the pollen. The knowledge survived, but it survived in communities that industrial food systems had already displaced and ignored. When native food sovereignty movements began gaining traction in the two Kansans, cattails were among the first plants highlighted as examples of indigenous agricultural knowledge that Western science had dismissed. Researchers like Enrique Salaman documented how tribes managed cattail marshes as agroecological systems, using controlled burns and seasonal harvesting to maintain productivity. This was not primitive foraging. This was sophisticated land management that modern agriculture had simply refused to learn from. The modern rediscovery has been slow and fragmented. Survival food bloggers in the 2010s began posting tutorials on how to identify and harvest cattails. YouTube channels dedicated to primitive skills and bushcraft featured them prominently. But the mainstream food industry has not touched them. Whole Foods does not sell cattail shoots. No startup has attempted to commercialize cattail flour. The infrastructure that would make it possible, mobile processing units, cold chain logistics for fresh shoots, marketing campaigns to overcome the swampweed stigma, would require investment that no one is willing to make. Because the return on investment is not there, you cannot build a billion-dollar brand around a plant that grows for free in every state. So here is what you need to know if you want to reclaim this food source yourself. Cattails grow in shallow water, typically 6 inches to 3 feet deep, in marshes, pond edges, and slow-moving streams. They are identifiable by their distinctive brown seed heads in late summer and fall, but the plant is present year-round. The young shoots are best harvested in spring, from March through May, depending on your latitude. Look for shoots that are 6 inches to 2 feet tall. Cut them at or below the waterline. Peel away the outer leaves until you reach the white core. This is the edible part. It can be eaten raw or cooked. The immature flower heads, the part that becomes the brown seed head, are edible when they are still green and wrapped in leaves. Harvest them in June or early July before the pollen forms. Boil them for 10 to 15 minutes and eat them like corn on the cob. The texture is similar, though the taste is blander. The pollen is harvestable in late June or July, when the male flower heads, which grow above the female seed heads, release bright yellow powder. Shake or tap the flower heads over container to collect it. The pollen can be mixed 50-50 with wheat flour to make pancakes, bread, or muffins. It adds protein and a slightly sweet flavor. The rhizomes, the thick roots, are the most calorie-dense part. They are best harvested in fall or winter when the plant has stored the most starch. Dig them up from the mud, wash them thoroughly, and peel away the outer layer. The core can be eaten raw, though it is fibrous. For flour, the rhizomes can be dried, pounded, and soaked in water. The starch separates and settles at the bottom. Pour off the water and fiber and dry the starch. This is cattail flour, and it can be used like any starch-based flour. But know the risks. Cattails are bioaccumulators, meaning they absorb heavy metals and pollutants from the water they grow in. Do not harvest cattails from polluted water sources, industrial areas, or roadsides where runoff may be contaminated. Only harvest from clean, natural water sources. Also, be certain of your identification. The young shoots of cattails can be confused with the young shoots of poison iris, which grows in similar environments. Poison iris leaves have a distinct ridge running down the center, and they smell unpleasant when crushed. Cattail shoots are round, hollow, and have no strong smell. If you are uncertain, do not harvest. They drained the wetlands to grow corn. They reclassified marshes as wasteland to justify the drainage. They built a food system that requires seeds, chemicals, and loans. And in the process, they erased a 10,000-year-old agricultural tradition that required none of those things. Cattails still grow in all 50 states. They still produce 15,000 calories per acre. They are still edible in 30 minutes. And they are still sold nowhere, because a food system built on dependency cannot tolerate abundance. But the plant does not care about economics. It grows anyway. It has been growing for 10,000 years, and it will keep growing long after the tractors stop running. Now you know what your ancestors knew, and now you know why they wanted you to forget. If you found this valuable, subscribe and share this with someone who needs to hear it. The next discovery is coming soon.